Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Okay, our topic today is electromechanical system. Okay, for this system we want to find mathematical equation. Okay, after we know the mathematical equation, we can find transfer function for this system. Okay, this one is same as a mechanical and electrical. So first we must know the concept of the system. Okay, the idea of electromechanical system is the combination of electrical and mechanical. So that's why we call as a electromechanical system. Okay, so electromechanical system basically example we can see the simple example is a motor. Okay, so you can see this figure. Okay, there are two parts. Okay, there are two systems. Okay, first is electrical system. Okay, this one is a mechanical system. Okay, for electrical system, we have input, we have resistor, inductor, and then also the current. This current we call as a armature current. Okay, but for electrical we have another component. Okay, so we call this one is a stop. Okay, so that's why this one VB. VB is a voltage EMF. Okay, and then this one is a fixed field. Okay, this fixed field produce the magnetic flux and then enter here. Okay, is a generate electrical, and then lastly the motor will be turned on. Okay, for the mechanical system you can see here we have a top and then we have a displacement output. Okay, this one is a block diagram. Okay, simple block diagram. Okay, this one is output and then this one input. Okay, and then this one GS is a transfer function. Okay, this is about how the electromechanical system is work. Okay, so from a magnetic field. Okay, so this magnetic field will produce a fixed field. Okay, will produce fixed field by stationary electromagnet or permanent magnet. Okay, so for magnetic field, so it will rotate the armature. It will rotate the circuit and then to produce current. Okay, so you can see IE. IE is a armature current, and then this current will pass to the magnetic field and to produce force. Okay, F equal B L I E L I E. So IE is a current, L is a length of the inductor, B is a magnetic field strength. Is a constant number. Okay, so from here, okay, this one in mechanical system. Okay, this one is a electrical system. So what happens to the electrical system? Okay, a conductor moving at the right angle to the magnetic field generate a voltage at the terminal. Okay, so you can see here, this one is a electrical. Okay, voltage. Okay. So this voltage will voltage we call as a electrical armature. Okay, so E equal BLV. Okay, B is a magnetic field strength, L is a length of conductor, V is a velocity. Okay, this one is explanation how we get the mathematical equation. Okay, first we solve the equation in terms of electrical. Okay, so first we must know the relationship between voltage. Okay, voltage P is a voltage at the motor, and then this one is a displacement output. Okay, so we can see this one voltage is proportional to the speed. Okay, This one is a constant number, KB. Okay, and then for this one, you taking Laplace. Okay, taking Laplace transform and then you get this one. VB equal KB S theta M S. Okay. Okay, and then if we're back to electrical circle. Okay, so here. So and then you can get this one. Okay, electrical mathematical equation RA plus LA SIA plus VB. Okay, this one in the electrical part. Okay, this one for mechanical system. Okay, so this one the relationship between torque and IA. Okay, so Tm equal KT IA. Okay, this one is a constant number for torque. Okay, and then for this one you can get this I. Okay, so IA equal Tm divided by KT. Okay, so you get you know what is the IA. You just replace IA in the previous electrical mathematical modeling, and then you get this right. Okay. Okay, this figure show the equivalent mechanical loading on a motor. Jm is the equivalent initial at the armature and include both the armature initial, and as we see later, the load initial reflected to the armature. Okay, so sekarang we want to convert the equation. We bukan convert, we want to combine electrical and mechanical. Okay, so for this figure, we can find Tm equal Jms square plus Tms multiply theta m. Okay, this one from this figure. And then, okay, so previous Tm, okay, so Tm here, you can replace into this, replace Tm into this equation. And and then you akan dapat equation this one. Okay. Okay. Now we assume that armature inductance LA. Okay, this one LA is small compared to the armature resistance. Okay, so we consider LA is too small. Okay, so we just cancel out. Okay, or we just ignore. Okay, and then lastly you can get RA over KT multiply GMS plus DM plus KB, and then multiply by S theta M equal EA. Okay, after you get the equation, okay, you simplify. Okay, after we simplify this one, theta M is output, AA is a input. So we can get this one, KT over RA multiply JM and then divide by S, okay, bracket, okay, S plus 1 over JM, okay, bracket DM plus KT KB divided by RA, okay. So this finally equation. Okay, but if you have this one, okay, 2 gear here, so we just need to know the relation between N1 and N2, so you can get this equation. Okay, you can derive and then lastly you akan dapat equation something like this. Okay, so JM, okay, JM here, JM is a equivalent ataupun JM is a initial of motor. Okay, so you combine this one, okay, and then you akan dapat lah this one. Okay, so JA kat sini, okay, JA is here, and then JL is here. So JM is a equivalent initial of motor. Okay, so and then we consider LA equals 0, and then lastly you can get this equation. Okay, Tm equal minus KB KT over RA omega M plus KT over RA EA. But in electromechanical system, this This part is a very important. Okay, this one is the relationship between torque and speed. Okay, so here you need to know what is the relationship between torque and speed. Okay, so basically torque speed curve is a straight line. Okay, and then to find, okay, so dia ada satu istilah, okay, is a one istilah we call as T-store. T-store equal KT divided by RA EA. Okay, to T-store here happen when omega angular velocity equals 0. So when, okay, so previous this one, okay, the previous equation, okay, this one, okay, so EA equals 0. Okay, this one, omega m equals 0, so you just put here, so you can get this store equal KT divided by RA EA. Another term you need to know is omega no load. Okay, omega no load speed. Okay, this one happen when T equals 0. So, previous equation, okay, this one is a 0. Okay, so you want to find omega m, okay, omega no load. So you taking this one to this side, okay, so you cancel each other, and then lastly you can get omega no load equal EA over KB. Okay, so lastly you can get this equation, okay, the electrical constant of the motor's transfer function. Okay, KT over RA equal T store over EA, and then KB equal EA over omega no load. Okay, this one is just a form two equation here. Okay, I think that's all for electromechanical system. Okay, but for example, I can explain in other video. Okay, so I hope you can understand. Okay, concept of electromechanical system. Okay, so the idea how you to understand this concept. So you can watch the video more and more, and then you can write down, and then you can take note. Okay, so hopefully you can understand the concept of electromechanical mechanical system. Okay, that's all for this video.